Hello and welcome to an easy unit, AP Chemistry Unit 2. Let's see some questions to prove that this is a very easy unit. Which of the following predicts the type of bond that forms between silicon? Is it silicon? It's S, sulfur, and fluorine. Is this a non-polar? Is a polar covalent? It's ionic and metallic. That's a very easy question. Whenever you see a bond that's happening between a metal element and a non-metal element, is an ionic, and this is not the case here. If I have a look at the periodic table, I will see that the sulfur and fluorine are both are here. Both are on the right side. This is the non-metal side, yes, at the right of the ladder. The metallic is usually if I have a metal like sodium, atoms from the same element of sodium, so metal only, and the same element, so metallic. Sodium alone, potassium alone, aluminum alone. If it is a metal and non-metal, it's a covalent. But is it non-polar or polar? If the fight on the electrons is very strong and there is a big difference between two elements, like one is on the right and one on the far from it, then it's going to be a polar covalent. But if they are similar or there is not much big difference in the electronegativity, it's going to be polar covalent. Have a look at the periodic table very fast to see. So look here at sulfur and fluorine. Here is sulfur and here is fluorine. So the good difference between them, which makes it a polar covalent bond. A polar covalent bond when there is a big difference in the electronegativity, or at least a medium one, not a small difference. Which of the following bonds is likely to have the least ionic character? You are talking about the least or the weakest ionic character. In order to have a good ionic character, you need to make a bond between two elements which are very far from each other. Is it between the magnesium and the oxygen? Is it between the carbon and fluorine? Is it between the nitrogen and the oxygen? Or it's between the calcium and fluorine? So we don't need to pick things which are very far from each other. We don't want the ionic character. We want a covalent character. We want elements which are as close to each other as much as possible. So let's have a look. Magnesium and oxygen, very far from each other. Calcium and fluorine, very far from each other. I will not pick these two. Now I have carbon and fluorine. So carbon and fluorine still a little bit far from each other. And then nitrogen and fluorine. I think nitrogen and fluorine, this will be the closest to each other. So I will get this as the worst option. I don't want to use the nitrogen and oxygen. I don't want to use the nitrogen and oxygen because they will have the least ionic character. I don't want this to be ionic bond, so I will choose this as the correct answer. These two cannot form an ionic bond. They will form a covalent bond, and there's very little difference in the electronegativity between them. So I will not use the other three. And the third question, based on the information in the table, which of the following arranges the bonds in order of decreasing polarity? If you want to decrease the polarity in a covalent bond, you need to make a small difference in the electronegativity. So let's have a look. I have basically three different bonds here which are repeated all the time. The bond between the chlorine and fluorine, and I can see the difference between chlorine and fluorine as 0.8. And another bond which is repeated here is the bond between the selenium and nitrogen. So I can see selenium here is 2.6 and nitrogen is 3. So I have 0.4 difference between these two. And the last bond which is repeated here is the bond between the hydrogen and iodide. So hydrogen is 2.2 while iodide is 2.7. So these have 0.5 difference. So the biggest difference in the electronegativity means the biggest polarity. So the highest polarity is 0.8. Where do I see that the highest polarity is 0.8? This means that CLF, these two options are okay. The next one in the strength of the polarity is the 0.5 because this has the next value for the difference in the electronegativity. That's the bond between the hydrogen and iodide, which is here. And the weakest one is the difference between the weakest polarity is between the nitrogen and the between the nitrogen and the selenium. Nitrogen and selenium has 0.4 only difference. So since this is the smallest difference in the electronegativity, they have the smallest polarity. So hydrogen and iodide is the weakest. Nitrogen and selenium, sorry, nitrogen and selenium. So nitrogen and selenium is the weakest polarity because it has the smallest difference, that's 0.4 only in electronegativity difference. In the next question, which of the following correctly shows the bond polarity? Bond polarity happens when there is a difference in electronegativity between two elements. One of them has more electronegativity than the other, so it will attract the electron to itself more, and it will have a partial negative, while the one that attracts the electrons less has a partial positive. So let's have a look. I have here sulfur and sulfur. Is there a difference in electronegativity? For sure there is not. They are the same elements. So we cannot have the same elements and they have the same bond have different electronegativity. They have different electronegativity. No, for sure they are brothers. They cannot have different electronegativity, so it's wrong. The second comparison is between the carbon and the silicon. The silicon is down and the carbon is up. What happens to electronegativity? When you go to the right or when you go to up, the electronegativity increases. So this way the electronegativity increases when you go to the right or you go up. When you go down or you go to the left, the electronegativity decreases. So let's have a look what happened here. You went from carbon to silicon. So you went down, so electronegativity decreases. So silicon has less electronegativity, so it attracts the electron less, so it will be partially positive, not negative. So this is the wrong answer. Now let's have a look at gallium and bromine. The gallium here is on the left and bromine on the right. So when you go to the bromine, the electronegativity increases. So should have the negative. So bromine should be negative, which means that this is the correct answer. Now let's look at the last one. Don't forget, when you go to the right and up, electronegativity increases. The ability to attract the electron becomes more. The last one is between chlorine and phosphorus. Chlorine is here and phosphorus is on to the left. So phosphorus is on the left. The electronegativity decreases. Phosphorus has less, so it is partially positive, not negative. So this one is wrong also. The only right option is C. In question number 5, which of the following best describes the bond between Br and Br? Two friends together, Br and Br. Do you think there will be a fight between them? Do they fight for the electrons? No. That's why the covalent bond still is there. It's a non-metal and non-metal, but it's not ionic and it's not metallic. But is there a difference in electronegativity? For sure, no. So of course, it's not polar. It's a non-polar covalent bond. Whenever you have two elements together, whenever you have two bonds together and you are trying to find the difference in electronegativity, they are the same atoms. They are the same atoms. There is no difference in electronegativity. So it's non-polar covalent. A very similar question is asking about the difference between CS and Cl and what type of bonding they are forming. The CS and Cl, one here is on the right non-metal and one here is on the left a metal. So of course it is an ionic bond.